The next topic is how the Guru PC protects passenger train cars from freezing, presented by Glenn Quinty. Glenn is a senior design engineer at ThermOmegaTech. Glenn, we'll hand it over to you now.
So yeah, this will be on our standard Guru PC valve, which is used on passenger car trains. And so what we're going to start with is the need for freeze protection. So why would you need it? Well, obviously, as everybody knows, water when it gets below 32 will freeze and expand, which could crack pipes. So I'll just read off some here and I'll extrapolate as needed. So without a proper freeze protection solution, passenger cars' potable water bearing systems are at risk of freezing. Typically when a car's heat is turned off during a layover or a locomotive switch or power outage, again, in freezing weather. But the consequences of that are burst or cracked pipes, which would interrupt the kitchen galley systems and sanitation systems, which then result in very costly and lengthy repairs. The heart of what we do, the ThermOmegaTech as a company and the Guru PC specifically, is it's a self-powered actuator. As you see this little fluctuating animation on the right there. We're founded in 1983, and we've been protecting diesel locomotive cooling systems from freeze damage using the thermal actuator technology. So thermal actuators, how do they work? Utilizing a registered thermaloid material within our wax actuators. It's basically a paraffin-based wax. The diaphragm expands as temperatures increase above the material's melting point, pushing on a piston to open or close the valve's hot position. The piston then retracts as the thermal material cools, and the diaphragm returns to its cold position. And our standard temperature range right now is around 15 degrees F to 300 degrees F. And if you look to the right, you see that little animation going back and forth. What that's showing is the wax in the blue and red. When it's blue, it's cold. When it's red, the wax expands roughly 14 to 18%, which it has nowhere else to go but other than to push the hermetically sealed diaphragm forward like that. And what we do is we take advantage of that stroke motion, as you see at the very far end with that piston moving in and out. Listed right above that animation is direct acting versus reverse acting. The Guru PC valves is what we consider a direct acting valve, meaning that it opens upon temperature fall. So in other words, since it's a freeze protection valve, the wax that we use in there is down around a 35-degree wax. So at room temperature, it's actually hot. As the temperature falls down below right 235, it's going to start to change its phase and go from a solid in the blue. From a red. It's going to go from liquid in the red back to a solid in the blue. Once doing that, the valve opens up and drains the whole system out. The reverse acting, so the direct acting helps keep systems warm. The reverse acting, which would be other types of valves that we offer, do the exact opposite. They start out in the blue phase there, with the actuator retracted, the piston retracted, and when it reaches a certain set temp, depending on what temperature wax you're using, the piston will extend out, opening it and relieving the hotter media, waiting for cooler media to come and revert the wax back from its liquid form back into its solid state. So yeah, the benefits of thermostatic valves. Well, the main benefit is it's self-powered. Which means it can be located virtually anywhere, requires no electric, hydraulic, or other power, ideal for winter storms and power outages. They're used as the main source, or matter of fact, as backup and fail-safe for other powered systems. They're virtually maintenance-free, very predictable. They have a very simplistic design, as you saw in the little animation beforehand. And what's important in pretty much all areas of industry, especially like aerospace, is the actuator component has a high power to weight ratio, allowing for a compact size while still providing optimum valve performance. So you're always trying to get smaller, lighter, and more powerful. So the Guru PC passenger car freeze protection valve, So what it does is it protects the train's potable water bearing system, as I said before, from freezing in the winter season. So the operation, it is self-operating. It is NSF 61 certified, meaning that we have it certified by an independent agency to make sure that there are no type of carcinogenic components, especially lead. That's pretty much what they're looking for. Anything that could back up into the system and possibly harm someone. Certified group valve constantly monitors the ambient temperature. Should the temperature of this little actuator at the top here, you can see this right here, should that fall below the set point 35, the valve will modulate open to drain the water before freezing can occur. Once power and heat are restored, the valve modulates back closed again. The electric heater assembly, which we say preferred, I'll say why in a minute, closes the valve within minutes of power up to allow refilling of the potable water system after drain occurrence. Now, the reason we say preferred is because this valve on its own, when it's installed in the water bearing system on a railroad passenger car, will definitely freeze protect the valve without any issue. The problem that could happen is if it's below 35, let's say down around 20 degrees, and there's a car that's been taken out of service for either maintenance, repair, or whatever. Now it's been ready to be put back in operation. Once they apply the power, if you don't have this heater on there, because these are located usually either between the walls in the passenger car or in like small utility cabinets, you'd have to wait for the whole interior ambient air to heat up above 35F, which could take a couple of hours. And what we did was we developed a heater that you put on there that you connect to the floor heat, so that when the car power is applied, the floor heat will be on. It heats up that electric heater assembly, and you're up and running when about, I say, 5 minutes maximum. So we have a little demonstration here, and what you'll see from this demonstration is how the Guru PC reacts to ambient temperatures, the water draining once set temperature is reached, and the heater assembly quickly closing in the valve.
Hi everyone, thanks for tuning in to today's webinar on our passenger car freeze protection. I'm Dana Logue, Railroad Product Manager here at ThermOmegaTech, a Logue family holdings company. And with me today I have our Senior Design Engineer, Glenn Quinty, who is also today's presenter. So today we're going to be demoing our two valve sizes that we have. We have the 3/4 inch Guru PC over here, as well as our 1 inch Guru PC. The main difference between the two is just going to be the flow. The 1 inch Guru PC offers double the flow. So what we want to show you today is how our thermal actuator technology works. It senses the ambient temperature rather than the water temperature. So when the valve set point as 35 degrees Fahrenheit, when the ambient temperature gets to that set point, it's actually going to modulate the valve open to drain your potable water tanks before any freeze damage can occur. So we'd like to show you how that works today. I'm going to go ahead and pour this in. Both of these here.
Perfect.
So now we're going to show Glenn using a quick freeze spray to simulate ambient temperatures getting close to 32 degrees Fahrenheit. And what this is going to do is going to modulate the valve so that it's open and the potable water tanks will drain. So Glenn, if you want to go ahead and spray that actuator, and let's just show how the valve works without any power or any electricity. So here you can see within seconds, the valve modulates open to drain your tanks before any freeze damage can occur. So it's very quick acting.
Something like whatever. Yeah.
So how do you get your potable water tanks refilled and back in operation as quickly as possible? Well, we've actually developed a heater that acts as a cold water refill tool. So I'm going to have Glenn demonstrate how this heater works. So what it's going to do is it's going to heat up that actuator to close off the valves so that you can refill your tanks without anything any water draining. So once it's plugged in, you're going to see that there are two indicator lights. The first indicator light is going to show that the power is on, and the second is going to show that the heater is working. So here you can visibly see that the heater is working and the power is on and it's functioning properly. We do offer two different heater options. We have 120 VAC, 74 DC dual voltage heater, as well as a 230 VAC heater. These heaters are self-limiting, so you'll never overheat your actuator. So we hope that this was educational and you learned more about how our valve and heaters operate to protect your investments in your passenger cars. Thanks again for tuning in, and now back to the presentation.
Okay, great. Glenn, thanks for putting that on. That was great information for all of us. We've got a few questions.
Okay.
Question number one, are these valves CE and RoHS compliant, shock and vibration tested?
Yes, they are. On all three, matter of fact, all by independent agencies.
Okay, all right. How often does the Guru PC valve need to be replaced?
So on an annual basis, you'll want to check it outside the freeze season, right before the freeze season starts, by hitting it with a little bit of freeze spray, like we showed, to have it open up. And usually within, I'll say 1 to 2 years, well, after the second year, if you start to notice when you perform that test that you see a little bit of leakage and the temperature is above, I'll say 50 degrees F, that means that the actuator assembly could be starting to wear and fatigue, from which we do have a rebuild kit that is easily installable. You don't have to remove the T-body at all. That remains solidly locked into the plumbing arrangement.
Oh, so, okay. Oh, that's good to know. Okay. Can the Guru valve be retrofitted into existing systems on passenger cars and or replace existing freezing protection solutions that might be already in place?
Yes, it absolutely can, because it's a standard 1.7" spacing and a 3/4 NPT between the inlet and the outlet, which was established years ago.
Okay. Well, Glenn, thanks so much for putting that presentation on. It was great information. If you have any further questions, audience, feel free to reach out to Glenn through the question and answer. He'll be on here for a little bit. If not, we can get you their contact information. But once again, Glenn, any closing remarks or anything you want to say, kind of close it up for your demo?
I just want to thank you for giving us the opportunity, Mike.